Yeah. So can we just try this problem? This I don't know if you can see the problem. I'm not sure. The problem says that x is binomial 10, 0.6, and define b naught as the one that minimizes e of mod x minus b whole squared in expected value. What would be b naught? Way to do it is you can compute it directly by finding this particular expression given the distribution of x. So one method one. So the idea is that you minimize x, and so you just find f of b is expected value of x minus b squared, right? And that can be tedious. So that's one way you can try. It will be like summation over k equal to 0 to n. You have k minus b whole squared, and then you have n choose k, and n is 10, so it's 10 choose k, and then binomial p is 0.6 whole squared, 0.6 to the power k, sorry, and 1 minus 0.6 to the power 10 minus k is a function of b, and then you could minimize it. Right? But this it's kind of hard to do. So it's kind of hard to do. And then you can go ahead and minimize f over b using calculus. So n is 10. I'm sorry, right? Using calculus. But this is hard to do. So this is hard to do. So not impossible, but you can differentiate and say it equals 0 and times solve to b. But the probabilistic way of understanding this is the following. It's a little trick. If you know the answer, if you don't know the answer, it's a little problem to guess the idea. The idea is the following. See, now you take expected value of x minus b. So you're trying to minimize, in general, the deviation from b whole square. Right? So the trick is you add and subtract the mean. So let's say you let mu be equal to e of x. So in this case, mean of binomial is what? It's 10 times 0.6. So that's equal to 6. So that's something you have a handle on. So what you do here is you go here, your expected value of x minus mu is you add and subtract the mu. Then you have a plus b, minus b. So once you have this, you're in business, because now this would imply. So let's come back in a second. So here's mu is separate. So let's. So now here I just do a complete the square, right? So I just expand it. So I have in the bracket I have x minus mu whole squared plus mu minus b the whole squared plus 2 times x minus mu times mu minus b. That's clear so far. I just expanded the square. Now move on to the sides of the square. So that's now. I'll leave the mu in green. I can't do that. So that's same as the expected value. So I'll leave this as x minus mu the whole square. The first term. The second term is a constant now. So it's mu minus b the whole square. It's constant. Because here expectation is across x minus mu and mu minus b and 2. So 2 and mu minus b are constant. So we just color them in pink. So it's 2 minus b is a constant. 2 is a constant. And so is mu minus b squared. So these two come out as the outside expression. And for this term, it's clear. For this term, what you do is you put 2 and mu minus b outside. It's a constant that comes out. And then you're left with e of x minus b. So what's e of x minus mu? That's this again. You leave this e of x minus mu whole squared. We know is the variance of x. Right? And this I leave as it is. I'll just leave as it is. So I'll leave as it is. This one is okay. 2 times mu minus b is again the same thing. Nothing going to change from this. Expression is linear, so this will be just e of x minus mu. But mu is e of x, so this part is 0. So this whole thing is 0. This whole thing is just 0. So this whole term is 0 now. So therefore, we have e of x minus b whole squared is variance of x plus this term right here, mu minus b whole squared. Very good. So now, once you're here, you're almost done now in this method. Here, you know that therefore we always know that e of x minus b the whole squared. See, the variance of x is a non-negative quantity, right? So the variance of x is a non-negative quantity. So this whole thing is going to be at least always 0 plus this particular term right here. Right? So this is true for any b in R. Right? So it's true for any b in R. So it's a very powerful inequality here. So e of any b in R, e of x minus b whole squared is always going to be bigger than mu minus b whole squared. So can someone tell me in chat what is the minimum value of e of x minus b whole squared? Then from this inequality. So I know e of x minus b whole squared is always going to be at least mu minus b squared. Can someone in chat tell me what is the value that minimizes the left hand side, that is the black part? What value of b will minimize it? So the idea is that it's always going to be bigger than or equal to this, and this part is 0 when mu is equal to b. Right? That's when it takes the smallest value. So therefore, we note that if b is equal to mu, then e of x minus b whole squared is just the variance of x. And that's the smallest value. So this part is always going to at least this. So maybe I should not have phrased it like this. So it's at least this. Maybe, yeah. So I'm sorry about that. The variance is non-negative. I made a mistake there. So I just meant to say this is bigger than or equal to this. This is non-negative quantity plus the variance of x. That's always going to be there. So it's going to be always bigger than equal to, it's going to be equal to this, and this is a non-negative quantity. So I'll put it as 0. I shall put this here first. I'm sorry about that. So e of x minus b squared is always going to be bigger than 0 plus variance of x whole squared. Variance of x. Here I'll put I made a mistake here. It's mu minus b whole squared is non-negative. So e of x minus b whole squared is always going to be variance of x, b variance of x. But when b is equal to mu, this quantity is equal to variance of x. So the minimizer is at b equal to mu. So therefore, the minimizer of B and R of E of x minus B whole squared is attained at B equal to mu. But here what is new in this problem? B was equal to mu was equal to 10 times 0.6, which is 6. So that's the answer. Is that clear? Can people on chat just tell me if it's clear or not clear? Very good. The answer is 0.6. But this one thing I want to just point out is in this analogy is the following, that this calculation here that we did, this calculation here is independent of the distribution of x. Okay, that's important. This part right here, it only asked if the variance of x is finite and the mean of x is finite. Okay? That's all it asked. So that's the advantage of calculation method 2. So method 2, you should note that this calculation right here is independent of x. It only required E of x to be finite and the variance of x to be finite. Once this happened, this calculation was independent of the actual distribution of x. Because I just did jugglery around. I just made a mess of this point right here, and I said I used variance of mu minus b whole square non-negative. But you observe that this part is non-negative, so it's always going to be non-negative, and you have plus variance of x. So E of x minus b squared is always going to be the variance of x, and it's equal to that quantity when b is equal to mu. So this one disappears. You have the answer. Okay, let's do the next question. The next question I had in mind was the following. Let's try and do this question. Random variable x has a PMF given by these numbers. So see solution to 6a. So what is it? It says E of x. You'll find E of x from the distribution, right? So let's see. So what's E of x going to be? E of x is the same as. So now, what all values x will take 0 times the probability x equal to 0. Maybe I should use it in back. Plus 0.2 times 0.2 times, sorry, not 0.2, say, plus 1 times probability x equal to 1, plus 2 times probability x equal to 2, plus 3 times probability x equal to 3. So that's what expectation. So like the person pointed out, 0 goes away, you have to calculate this. So 1 times probability x equal to 1 is 0.5, plus 2 times probability x equal to 2 is 0.2, plus 3 times probability x equal to 3 is 0.1. So the whole thing, if you add up, you get 0.5 plus 0.4 plus 3 is 1 point. Very good. So that's A. So what's B going to be? SD of x. So what's standard deviation going to be? It's a definition. Standard deviation of x, you can do it in many ways. One way is you can think of it as the square root of the expected value of x minus the mean, the whole square, x minus 1.2, the whole square. That's one way of thinking about it. The other way you can write it is, you can just think of SD of x as just E of x, the whole squared, sorry, E of x squared, sorry, squared minus E of x, the whole square, and square root. So can someone calculate and tell me on chat what they get? That seems a little high. Standard deviation seems a little high. It's a square root, right? Just try and see. Very nice. So something around that line. Right? So So that's kind of close by what you said. So let's see. So what you do is e of x squared is what now? So now e of x squared is going to be what is x? X takes value 0, so 0 squared times the probability x equal to 0 plus 1 squared probability x equal to 1, right? Plus 2 squared probability x equal to 2 plus 3 squared probability x equal to 3. That's the answer. And then square root the ax squared. And that's going to be equal to what now? Probability x equal to 1 is 0.5. The 0 goes away. It's 4 times 0.2, right? Plus 9 times 0.1. That's what I'll get, right? Very nice. And that's going to be 0.5 plus 0.8 plus 0.9. So it's 1.7 plus 0.5 is, is this correct? This is 2.2. Right. So that's the same thing as you get like, so the standard deviation of x is just going to be the square root of e of x squared minus e of x the whole square. And that gives you square root of 2.2 minus 1.2 the whole square. And that if you calculate some number, it's a 0.8 something. Very nice. How do you do the third part? What is the third part telling you? The probability that x will be produce a result more than one standard deviation from an expected value. So how do you do that now? Anybody on chat has to say anything, or you want me to try? So what you have to do, you have to find the chance that x is one standard deviation from me, right? So you just find the chance x minus mu is at least sigma, right? That's what you have to find. But sigma is what we found earlier, right? So this is around 0.8, right? 0.87. So this means what? This means x is bigger than mu plus sigma. But what is mu? Mu is like 1.2 and sigma is like 0.87 approximately. So this is bigger than is equal to probability that x is bigger than 2 point something, right? 2 point, let's say 7. But x is big. X takes values what? 0, 1. X belongs to 0, 1, 2, and 3. So only thing is x can be equal to 0.3. But 3, which is 0.1. That's the answer. Okay, what's the next question I want to do? Let's do this one. Try maybe an event like simpler one. Let's say b is equal to x less than equal to 2. Let me do this. And let me try and find e of x given b. So that way you all can do the assignment yourself of a x less than equal to 2. So how does one do something like this? E of x given b, the definition is what? The summation over k equal to x can take the values 1 to infinity because x is geometric. And probability that x equal to k given the value b, probability given b, times k, right? This is the expectation of the conditional expression of x given the value. Given b. Agreed? Is the definition clear? So all you have to do is you have to compute for this calculation. You have to compute the probability of x equal to k given b. What is that? That's the same as x equal to k and b divided by probability of b by conditional probability definition. But that's equal to what now? That's equal to probability x equal to k and x less than equal to 2 divided by probability x less than equal to 2. So let me compute the bottom part. Suppose probability x equal to 2, how do you calculate? So that's just x is geometric. It means x equal to 1 plus x equal to 2. And I've said x is geometric half. Geometric half means this is just the first success is a half. Here you have failure in the first one, which is half, and success second one, that's quarter. So whole thing is a 3/4. So that's the probability x less than equal to 2. Very good. Now the top part there. So let's make this a green. And let's make this perhaps the pink part. Let's say. So now let me just try and compute this pink part right now. This is going to be equal to what now? This is going to be equal to, so x is equal to k and x less than equal to 2. So if k is at least 3 and above, this probability is 0 because x can't be equal to 3 and less than equal to 2. So only point is let's do x equal to k equal to 1. Let's see. If k is equal to 1, this is the same as probability x equal to 1 because if x is equal to k and x less than equal to 2 and k is 1, then the only chance is k equal to 1. So it's going to be a half. And k equal to 2 and x less than equal to 2 means that x has to be equal to 2, and that's just a quarter. From the top part, it's just a quarter. So you go back up here, probability x equal to k given b is equal to this quantity right here. So therefore, probability x equal to k given x given b, the conditional law is 0 if k is bigger than 3, right? Is half when k is equal to 1. Something is wrong here. What have I made a mistake? Let's just check. Yeah. So half by 3/4, right? Half by 3/4 if k is equal to 1. That's the green part. And the last one is quarter by 3/4 is the k equal to 2 part. So let me just make this in this part is the green part, pink part, sorry. That's from here. And this part is the green part of it, right? So therefore, let me just redo this a little bit more. So probability x equal to k given b is 0 if k is bigger than 3. Here it's 1/2 plus by is 2/3 if k is equal to 1, and it's 1/3 if k is equal to 3. So that's the conditional distribution of conditional probability of x equal to k given b is what we have. So let's go back to E of x given b. So E of x given b was the sum from k equal to 0 to infinity k times probability x equal to k given b, and that's the same as so everybody above 3 is 0. So 1 to infinity. Everybody above 3 is 0. So only 1 and 2 remain. So 1 is 1 times 2/3 plus 2 times 1/3. And the expectation is 4/3. So what is the variance of x given b? So variance of x given b will just be, so you just take the expected value, right, volatility of x minus the mean, which is 4/3 whole squared, given the event b. And this is exactly what the conjugate expression, conjugate variance is going to be. So that's going to be equal to what now? X given b, that's the same as saying summation k equal to 1 to infinity k times probability x equal to k, not k times, sorry, k minus 4/3 whole squared times the probability x equal to k given b. But this we know has only two values, 1 and 2. Everybody else is 0. So when k is equal to 1, I have 1 minus 4/3 the whole squared times probability x equal to a given b, which is 2/3, plus 2 minus 4/3 whole squared times x equal to k given b, which is just 1/3. So what's this going to be? This is going to be 3 minus 4 is 1, minus 1 whole squared is 1, 1 by 9 into 2/3. 6 minus 4 is by 9, 6 minus 4 is 2, 2 squared is 4, 1/3. Right? This is what I get. So what do I get? I get 1/9 outside, I take out. So I have 2/3 plus 4/3. That's going to be 1/9 into 6/3. So that's 2/9. Very nice. Very good. Someone in chat got it correct. Very good. So that's the answer for the variance, right? Very good. So that's how you do the conditional variance also. So just find the same way, find the conditional distribution, and then use the same formula of variance as you did before. Very good. Now let's do the next problem. So this is a very sort of the last problem of the day. How do you do this problem? X is a discrete random variable. I want you to do Chebyshev's inequality and find the upper bound or the likelihood that x will be more than 2 standard deviations from the expected value. So how do you want to do this question? So I'll write the question down. So the question is just worded sort of in a way that's a little bit discrete perhaps. So let's say mu is E of x, right? And the standard deviation was sigma, was the square root of E of x minus mu whole square. Right? So what does Chebyshev's inequality tells you? So the Chebyshev's inequality tells you that the chance that x minus mu is bigger than a quantity k times, at least k times sigma, that is, it's away from k times sigma, right, is, so this x minus mu is bigger than k times sigma, is always going to be less than or equal to 1 over k squared. That's what Chebyshev's inequality tells you. Right. And this is what it means. X will be more than 2 standard deviations of x value. Just means this, right? That means what? Means k is equal to 2. That means that is k is equal to 2. So if you apply the inequality, if you want to find out for a random variable x minus mu is at least twice the standard deviation, then that's going to be 1 over 2 squared, which is 1 over 4, which is 0.2. Why did you say 11.25? I didn't see that. But is this clear? The argument is clear for you or no? Because x is any discrete random variable, so it will always be it will have a mean mu finite. Assume mu finite. Assume sigma is finite. So the Chebyshев inequality tells you that probability x minus mu bigger than k sigma is less than or equal to 1 over k squared. Okay, that's all I had for today. Thank you. Bye bye.